A massive blackout triggered by a solar storm wouldn't just plunge cities into darkness, it would send shockwaves through every aspect of modern civilization. Unlike local outages caused by weather or equipment failure, a Carrington-level event could knock out power grids on multiple continents simultaneously, triggering a chain reaction of global disruption. At Infinity Beyond, we trace what would happen hour by hour as the modern world loses its most essential lifeline: electricity. Within the first minutes, internet servers go down. Data centers, even those with backup systems, begin shutting off non-essential operations. Air traffic control loses contact with multiple aircraft. Hospitals, overwhelmed with emergency cases, begin triaging power use. In less than an hour, banks suspend transactions. ATMs go dark. Stock markets around the world cease trading, either through algorithmic failure or power loss. Water pumping stations, reliant on electric motors, stop functioning. Taps run dry. Gas stations can't operate pumps. Vehicles stall. Deliveries halt. Fuel supplies begin to choke. After 24 hours, cities are in chaos. Refrigerators fail, spoiling food. Security systems, including cameras and alarms, go offline. Cell towers and Wi-Fi routers stop working, rendering communication nearly impossible. Satellites, without proper shielding, suffer cascading failures. GPS becomes unreliable. And after a few days, the deeper, slower crises begin to take shape. Hospitals run out of generator fuel. Supply chains collapse, affecting everything from food to medicine. Public trust deteriorates, giving way to panic buying, looting, and misinformation. Digital money becomes meaningless, as banks remain offline and no transactions can be processed. Even your smartphone, fully charged, becomes a glorified flashlight once networks vanish. At Infinity Beyond, we explore how fragile our modern society really is. It's not just our comfort that depends on electricity. It's survival. In the age of the cloud, even critical infrastructure like traffic lights, emergency broadcast systems, and police databases depend on centralized servers powered by electricity. A blackout of this scale would also paralyze governments. With no internet, no real-time updates, and no command centers, decision-making reverts to pre-digital methods. Paper, radios. In some areas, nothing at all. One of the lesser-known consequences is the psychological effect. With no light pollution and communication outages, people may look up at the night sky for the first time in years, only to see nothing moving. No aircraft, no satellites, just silence. A world unplugged. Yet there is hope. Some nations, like Sweden, Germany, and South Korea, have begun building hardened microgrids, localized power systems that can operate independently. Others are exploring low Earth orbit satellites resistant to radiation storms. The key to survival isn't preventing the storm, it's preparing for it. In our next segment, we'll investigate how the sun's impact on Earth might even extend to triggering earthquakes, and how researchers are discovering strange correlations between solar activity and geophysical disasters. Because when the lights go out, the Earth itself may begin to tremble. For decades, researchers have quietly noted a strange and unsettling correlation. Periods of heightened solar activity, especially intense solar flares and geomagnetic storms, often align with major earthquakes on Earth. While causation hasn't been conclusively proven, the patterns are too consistent to ignore. At Infinity Beyond, we explore this eerie link between space and seismic chaos, a relationship that could reshape how we view Earth's internal stability. The theory goes like this: when the sun releases a coronal mass ejection, CME, it sends an immense wave of charged particles toward Earth. Upon impact, these particles don't just interact with satellites and power lines, they also penetrate Earth's magnetosphere and ionosphere, triggering changes in atmospheric pressure and electromagnetic stress in the crust. Think of Earth as a stretched rubber band. Over millions of years, tectonic plates grind and build tension. But could external geomagnetic pressure act as the final nudge that snaps the band? Some researchers say yes. One of the most striking examples occurred just months before the devastating 2004 Indian Ocean earthquake and tsunami, which measured 9.1 on the Richter scale and killed over 283,000 people. That year, the Sun released an unusually powerful X-class solar flare, which triggered strong geomagnetic storms on Earth. Other instances, like the 2011 Tohoku earthquake in Japan and the 2010 Chile earthquake, were also preceded by bursts of solar activity. In each case, the solar events preceded tectonic events by days or hours, leading some geophysicists to speculate that electromagnetic interference may contribute to fault destabilization. Of course, this theory remains controversial. Skeptics argue that earthquakes have occurred for billions of years, long before human beings tracked the sun. But proponents of the idea counter that solar-triggered earthquakes don't create new faults. They simply accelerate the failure of already stressed zones, acting as a cosmic catalyst for an already inevitable event. At Infinity Beyond, we believe this question is more than academic. If proven, this link could revolutionize earthquake prediction, adding solar activity as a key warning factor for seismic hotspots like California, Indonesia, and the Pacific Ring of Fire. Government agencies and research institutes are starting to take notice. Japan's National Institute of Information and Communications Technology, NICT, has begun integrating space weather data into early earthquake models. Meanwhile, NASA's Heliospheric Division is funding research on the geo-effectiveness of magnetic perturbations on tectonic regions. Could the Sun be Earth's invisible finger on the trigger? It wouldn't be the first time celestial bodies have influenced geology. The Moon causes tides. Jupiter affects comet paths. It may be time to accept that the Sun does more than shine. It may shake the ground beneath our feet. In our next segment, we'll bring this all together. From satellites falling from the sky, to pacemakers malfunctioning, to blackouts and earthquakes, what does a worst-case scenario solar storm actually look like? Because one day, all these warnings may converge. And when they do, it won't just be a bad day on Earth. It will be the day the Sun strikes. Let's imagine the worst-case scenario. A Carrington-level coronal mass ejection, CME, the most violent class of solar storm, launched directly at Earth in the year 2020, right as we enter the peak of solar cycle 25. The Sun ejects billions of tons of electrified plasma, moving at 2,000 kilometers per second, headed straight for our planet. And this time, we're not on the lucky side of orbit. At Infinity Beyond, we walk you through what this day could look like. Not to cause fear, but to help the world understand the stakes. Hour 0. Impact. NASA satellites detect a fast-approaching CME, but because solar flares travel at the speed of light, the X-ray burst has already hit, causing radio blackouts worldwide. High-frequency communications vanish. Transpolar flights lose contact. GPS systems show glitches and drifts, confusing navigation systems. Hour 1. The shock wave. The CME slams into Earth's magnetosphere. Geomagnetic storms rage. Satellites begin failing, either knocked out of orbit or bombarded by radiation. Weather data, financial transactions, global positioning, all disrupted. Some SpaceX Starlink satellites are pushed into atmospheric decay. Internet service begins to drop. Hour 3. Power grid chaos. Transformers start to hum, spark, and in some cases, explode. Canada's grid goes down. Sections of Northern Europe begin failing. U.S. power companies issue rolling blackouts to protect the infrastructure. But some areas, especially along long transmission lines, are hit hard. Hospitals rely on backup generators. Water purification systems stall. Cell towers begin to die. The world begins to disconnect.